Hello, AP Stat students. We're going to be looking today at section 10.2 again, but this time we're going to be doing a significance test. And the problem we're looking at is comparing Papa John's pizzas to Domino's. And reading the problem here, it says major national pizza chains often make claims about the quality of their pizza compared to their competitors. And you might have remember Papa John's slogan, better ingredients, better pizza. They actually got sued by some other pizza chains when they started doing that because other pizza chains said that that was kind of a false claim, and so they sued them. And you still know that slogan today. They still use it, so you can tell how that lawsuit actually turned out. But it goes on. It says here several pizzas were ordered at random times from Domino's and Papa John's to see if they have significantly different mean saturated fat contents. So I'm going to highlight something here for you so you see that. We're talking about whether or not they have significantly different being a key word, mean saturated fat content. So we're talking about the difference of two means, the mean fat in Domino's compared to the mean fat in Papa John's. And in this problem, we actually have the amount of fat that was in the different pizzas ordered from Domino's and the amount of fat that was in the pizzas ordered at Papa John's. And we're measuring fat here in grams, so it's the measurement being used for the fat there. When we do this problem, you are going to need your calculator because we're going to have to put that data into the calculator. And just so you know, when I use subscripts here, I'm going to use a capital D for Domino's, obviously, and I'm going to use a capital PJ for Papa John's. Just to make this match up with the work that we've already posted on Classroom, I'm going to put Papa John's into list number 1, and I'm going to put Domino's into list number 2. And it doesn't matter which one you do, you just have to keep track of which one it is. So if you want to, I've already put mine into my calculator. You can see the list here, list number 1, 6, 7, 11. You can tell that's the Papa John's pizzas. List 2, 17, 12, 10, that's Domino's. Go ahead and maybe pause the video and type that into your own calculator there so that you have it. Okay, now if you have that typed in, you know that what we're going to be looking for is we need the statistics about Domino's fat amounts and Papa John's fat amounts. So we're going to eventually go over here to Stat Calc and get the means and standard deviations for our two groups. But ultimately it says perform a complete significance test and then confirm your decision with a confidence interval. So we're going to work through here first the significance test. And you guys in my class know that I always like to and encourage you to record the information, the statistical information. So I'm going to go to Stat Calc and I'm going to do one variable stats on group number 1, which is actually Papa John's. And I'm going to come over here and record my information. So get the pen back. And here we go. So off the screen a little bit, that's okay. Papa John's. So here's what I have. I can see that the mean amount of fat in Papa John's is 6.533. I can see that the standard deviation for the amount of fat in Papa John's is 2.588, and that's in grams again. We can see that the sample size for Papa John's, when you typed it in, you had 15 pizzas. I'm going to go ahead and record right now that means the degree of freedom is 14. Over here for Domino's, the mean amount of fat in Domino's pizzas, I got to go over to the calculator and get that. So stat, one variable stats, we're going to do it on list number 2. And here we go. So Domino's, I can see the amount of fat on average in that sample was 11.25. The standard deviation was 3.193. And we had 20 pizzas in Domino's. I need an S there. The standard deviation was 3.193. The number of pizzas was 20. And that sample would have 19 degrees of freedom. Okay. That is my sample evidence. Based on that evidence, we have to try and make a decision. Do we think that there's a difference in the mean fat content between Papa John's and Domino's? So to do a significance test for that, we're going to go through phantoms. So here comes our phantoms work. I'm going to start out identifying the parameters. So we're using our Greek letter mu to stand for the mean fat content in Papa John pizzas. And then mu sub d is the mean fat content in Domino's pizzas. And I'm going to do my problem in this order. We're going to look at the mean of Papa John's minus the mean of Domino's. So everything I do in this problem is going to be done in that order. You could do it in the reverse order and you would end up making the exact same conclusion. So that's our parameters. Here come our hypotheses. The null hypothesis, remember when we look at the difference in these means, we are always going to say that null hypothesis says there is no difference at all. We're going to make the assumption that Domino's and Papa John's have the same average fat content. The alternate hypothesis is based on the question, and they said, do we have evidence that there is a difference in the mean fat content? So that didn't say that Papa John's is more, Domino's is more. It didn't give you a direction. It just said, we wonder if they're different. So I'm going to do that the mean Papa John's minus the mean of Domino's fat is just simply not 0. And you might remember this is going to tell you you're going to have a two-sided test here. All right, so we got our P and H set up. Now we're going to work through the conditions here. Lost the pen again. There it comes. Okay, so checking the conditions. So moving on in phantoms. It did say, if you want to look back at the problem in terms of random, it said that both samples were ordered at random times. So that kind of takes care of our randomness. Both samples were ordered at random times. We need to check the 10% condition. Our samples cannot be too big. Papa John's had a sample size of, how many pizzas did we have? 15. So we know there are definitely over 150 Papa John pizzas. Domino's, we had 20 in our sample. And again, pretty safe to assume there are over 200 Domino's pizzas. So we meet our 10% condition. The large counts condition is where you always have to do a little bit of thinking here. And this time especially, we have to go a little harder route here because the sample size for Papa John's was 15, and 15 is not bigger than 30. And the sample size for Domino's was 20, and again, that's not bigger than 30. So we can't get off on that easy way there. So what do you do when the samples are small? Well, that's where you have to graph the data. So I'm going to go over to the calculator and I'm going to graph it. What I'm going to look for is I'm going to look for that normal probability plot, and I'm going to check to see, and I got to do this for each one. Remember, each of these conditions up here, you have to look at, do you meet it for both samples? So we're doing it for Papa John's and doing it for Domino's for each of these conditions. So I'm going to go over here and I'm going to make a stat plot. I'm going to make a stat plot. I'm going to turn that plot on, and I'm going to come down here and get that normal probability plot. And I'm going to do it on list number 1, which is our Papa John's pizzas. And again, I'm going to do zoom 9. We'll quit out of that. We'll do zoom 9 so it picks us a good window. And we are looking to see, does that normal probability plot look roughly linear? And when I look at these 15 dots that represent the 15 pizzas, I don't see a real obvious curve. So I'm going to call that pretty good and pretty close to linear. So again, to emphasize that, I'm going to draw out for Papa John's. I'm just going to make a rough sketch. Real rough of the normal probability plot. And I'm gonna do the same thing for Domino's, and then I'll write about what I see in each one here. So here comes Domino's now. I'm gonna change that stat plot to list number 2. That's where we have the Domino's pizzas. And I'll redo the window, zoom stat. And I'm hoping to see again a straight line. This one actually looks a little bit straighter than Papa John's, so. Uh-oh. Do you see that? Looks like PowerPoint's freezing up. Come on, PowerPoint, don't fail me. There we go. Okay, Domino's, here we go. Rough sketch. I think I got them roughly in there. But I'm just gonna record this, talking about both. Both normal probability plots are roughly linear. They don't have to be perfect lines, but they need to be roughly linear. Both normal probability plots are roughly linear, indicating the data is roughly normal. So that's how we pass the large counts condition. And since we have passed all 3 conditions, we can now say what we're about to do. So I'm going to name the type of the test that we're doing here. We're going to say that all conditions are met. So I will do and here comes the name, a 2-sample t test. I'm doing a 2-sample t-test, and I'm doing it for the difference between the mean of Papa John's fat and the mean of Domino's fat. So that takes us through PHAN. That's half of the test. I'm going to go to my next blank page here, and now we got to actually do some of the math that is involved here with our test. So we're going to try and get a test statistic. Okay, so how do we do that? Well, in order to do that, I want to remind you that we're looking at, in my class, I would always draw out that sampling distribution. It's a little harder here with this pen, but we're doing a sampling distribution of the differences between these samples. What would we expect to see with the differences of these samples? And I'm going to go ahead and mark right in the center as 0. Remember why it's 0. It's because we're assuming in the null hypothesis that there's no difference at all between these fat contents. So that's 0. Now, what is this model? This is some sort of a T model. We'll figure out the degree of freedom here eventually, but it's centered at 0, and there's got to be some standard error too that we're going to have to calculate. So I'm going to go ahead and calculate what that standard error is. So we've got a formula on our formula sheet. The standard error says to do this. Standard deviation of group 1 squared over the size of group 1, standard deviation of group 2 squared over the size of group 2. I'm going to go ahead and fill in those values. We have those values from our sample statistics. So I'm looking back on my notes here. The standard deviation of Papa John's was 2.588, and there were 15 of them. The standard deviation of Domino's was 3.193. That gets squared. There were 20 of them. And if you calculate that on your calculator, you might want to pause right now, calculate that, see what you get. But I believe you get approximately 0.978. So that's my standard deviation of this model. Now, what we got to figure out, we still don't have a test statistic. We got to figure out what is the actual difference that we saw. Well, in our sample, the average for Papa John's, the average amount of fat, was 6.533. The average for Domino's was more. It was 11.25. And so what I need to mark is what is the actual difference that we saw. So if I subtract those two, 6.533, take away 11.25, I get an actual difference of our samples of negative 4.717. PowerPoint froze again. Doing too much work here. Here we go. 4.717. And that's what I'm going to mark up here in our model. That's what we saw as our difference, negative 4.717. So what we're going to try and calculate ultimately is what's the p-value for this. But we got to get our test statistic first. So the test statistic, the t-score, is the difference that we saw, subtract the center, which is 0, we're assuming it's 0, and divide by our standard error, 0.978. And we get a t-score of about negative 4.823. You might want to verify that in your calculator. Go ahead and stop and pause the video, and you can double check that. That is the t-step in phantoms right now. So if we want to get the p-value here, to obtain the p-value, I'm going to do O for obtaining the p-value. To get the p-value, now remember what that is up here. That's this area. That's what we want. But it is a two-sided test. Remember, it was a not equals to. So ultimately, we're going to have to double that and get all this area as well. So how do we do that? Well, you've got to do a t-CDF in order to get that. But to do a t-CDF, we got to know what is this degree of freedom that's supposed to go right in there. So I'm going to show you something on the calculator right now, and you're going to see now these these calculations are all a lot of work to go through. And this is one reason in this chapter why we've told you we're going to start relying on the calculator much more. So I'm going to actually have the calculator get these things for me, and I'm going to show you what the results are, and then we're going to verify them by hand. So if I wanted to do that, I'm going to run the test on the calculator. So go to Stat, go to Tests. We're doing a two-sample t-test. And the calculator says, what's the input? Do you have the stats or do you have the data? Well, I do have the stats written down, but it's probably easier. Instead of me typing all them in, I'm just going to say, hey, calculator, I've got the data in our two lists. They're in list number 1 and list number 2. So I'm just going to say, calculator, you look for those lists and get the data from there. The final line here says, what's your alternate hypothesis? We had a not equals to, so I'm going to change that to not equals to. And again, if the calculator ever asks you if you want to pool, your answer is always no. And then I'm going to go ahead and calculate this. I'll draw it here in a second, but I want to calculate so you see what it is. So when we calculate that, notice first thing it shows me, t-score, negative 4.823, right up here. That matches what we got. The p-value is calculating for us. It says 3.15, but out at the end, there's that e minus 5. So we got to remember that really means this is a very, very small p-value. But look what else it tells you. Degree of freedom, 32.7 about. So where would it get 32.7? Well, it's not doing the shortcut that we talked about before, where you just say, I'm going to go back in the PowerPoint. The shortcut we had before said, come on PowerPoint, there we go, said we just look at when you have these 2 degrees of freedom from the samples, you just pick whichever one is smallest. So I would have picked 14 here. But the true degree of freedom, if you don't use the shortcut, is actually 32.7 something. So how does the calculator get that? Well, I'm going to scroll through here a couple slides and have you see it. Close your eyes because this is going to be scary nasty. Next one. Here it is. To get the degree of freedom, the calculator is actually using this formula. Yeah, it is massive and it's nasty here. So when we do this problem, I would never actually calculate this out. In fact, I will tell you personally, I have never once done this formula because the calculator will do it for you. So I would much rather just have the calculator spit out the degree of freedom to me. So there it is. I'm just going to use that. So just understand your calculator will give you the degree of freedom if you want the true degree of freedom there. Boy, my PowerPoint is having fits tonight. Okay, I'm going to go back to the work that we have. So if I wanted to actually get that p-value, then I would do this. I would do TCDF, and I'm going to try and get that shaded region up here, all of this area here, and we would do from negative 99 to our t-score, negative 4.823, and you got to tell it the degree of freedom. I'm going to put in the actual one, 32.757. That's the degree of freedom. And I'm going to do that on the calculator and see what we get. So second distributions, TCDF, we're going to go from lower, negative 99, to upper, our t-score, negative 4.823, and we're going to punch in the degree of freedom, 32.757. If you use that shortcut of 14, you would be off a little bit with your p-value here. So this says 1.57, but there's that e minus 5. So remember that I've got to get, I'm going to record down here again, to get that p-value. The calculator just said this. I'm going to go ahead and move those zeros out. 0, 0, 0. I need one more, I think. 1, 5, 7. But I've got to double that because this is a two-sided test. So I'm going to go back to the calculator. If I double that, take that times 2, there's that result that we got when we ran the test on the calculator just a minute ago. So the actual p-value is, when we double that, is approximately 0.00032. So whatever you know about this p-value, you know that is super small. So that's a very, very unlikely result to get. That's a very, very small difference if the truth is that Papa John's and Domino's have the same mean fat amount in their pizzas. So we've gone through all the work. We've shown how to do it on the calculator. Remember, on the calculator, we just did stat and we did test. We did a 2-sample t-test. If we go back now on the calculator and instead of calculating, if we draw it, let's see what it looks like. So remember, when you draw it, it gives you that same t-score down here. The p-value just says is 0. The calculator is really rounding that off. It's not really 0, but boy, it sure is small. And the shading, you don't really see the shading much because it is so small, but it is shading both tails because it's a two-sided test. All right, let's finish this off. Let's make our conclusion here. So here's the final part to phantoms. So I've got to make a decision. My decision I'm going to make, remember what that p-value was. That p-value was about 0.00003 something. So I'm going to write this. I'm going to say that I reject the null hypothesis, and the reason is because that p-value, 0.00003, is smaller than, I don't remember if we said an alpha before, but we'll use our standard alpha, smaller than 5%, way smaller than 5%. So what does that make me think in the end? What do I say in context here? Well, if I reject the null hypothesis, then I'm going to say that I have convincing evidence for the alternate. But remember what the alternate said. The alternate said that the mean of Papa John's minus the mean of Domino's was something different from 0. In other words, those two mean amounts are not the same as each other. They are different. So I'm going to write that I have convincing evidence that the mean fat, sorry about that, PowerPoint's fading again. Come back. There we go. So I'm going to say I have convincing evidence the mean fat of Papa John's pizzas is different than the mean fat in Domino's pizzas. And that's all we can say in this hypothesis test, in this significance test. All we're saying is that we have convincing evidence that the mean amounts of fat are different from each other. Now, what we'll do to finish up, I'm going to go ahead and stop this video here in a second. We'll do the rest of it on a second video. But leaving you with this conclusion, it kind of just leaves you hanging. If you think you have evidence that the mean amount of fat in the two pizza chains is different, then it might make you think, oh, if they're different, then how different are they? Which one's higher? Which one's lower? How much higher? How much lower is it? And that's where you need a confidence interval to kind of say how different they are. And that's what we'll do in the next video. So I'm going to stop this video here, and we'll pick up the next one with a confidence interval.